we have seen different types of logic gates, and I have explained you about universal gates, and from the universal gates how we are able to design all other gates. Transistor level schematics we have seen with the operation. And I have given you the introduction about the Boolean algebra. Okay, today, so actually the Boolean algebra, it goes like this. We need to study on the axiomatic definition of Boolean algebra. Theorems are there, right? Theorems we will study. Boolean functions and digital integrated circuits. From their logic gates, not only logic gates, from these logic gates, all the other logical operations, how we can perform. And canonical and standard forms also we will see. Okay. So what is an algebra? Algebra is nothing but it is a mathematical system. Algebra is a mathematical system which consists of set of elements, set of operators, axioms. Axioms are also called as postulates. Okay. Set of elements means it may be what A, B, C, D, or it may be 1, 2, 3, 4 up to any number. Okay. Operators are plus, minus, okay, and operation, XOR operation, anything. Okay. So axioms are some postulates. There will be some rules. Okay, not rules, postulates. Okay, these are the proofs. Okay, so we can follow them. Why this Boolean algebra is why they are important is, so this algebra it defines the rules of calculations. When we are calculating something, we need to follow the rules. Okay, so algebra is giving that. And next one, if you see what are the example, if you see set of elements are 1, 2, 3, 4. Okay, operators. Axioms, what are the axioms? It may be associativity, or it may be distributivity, or it may be closure, or it may be identity elements, etc. Okay. See, operators with two inputs are called binary. Okay, two inputs. Let us what 0 and 1. These are the only two inputs. These are called binary. Okay. So doesn't mean they are restricted to only binary numbers. Why? Because we have unary operators also. See, if I'm uh, B, okay, here and operator, product term I'm using. So these are two operators, okay. So we call it as binary. But negation A, it is a unary operator, okay. So negation is the unary operator, okay. Operator with one input. It may also be there, okay. So see here, what is a set actually? Set is nothing but it is a collection, okay. It is a collection. It is a collection of having the same property. Here one set, we are seeing one set. What is this set? It is having a collection of some numbers, okay. So if x is equal to 2, then this x is belonging to this set. Or y is equal to 5, okay, y is equal to 5, then y it doesn't belong to this set, okay. So see here, y is not there in this set, okay, that's why I'm writing y doesn't belong to this set, okay. These are the small things, that's why simply I'm showing and skipping the slides. So binary operator defines on a set S of elements is a rule that assigns to each pair of elements from S a unique element. See, this one, for example, S is a set. Now we are considering xy is equal to z. Now here this this product term is a binary operator, okay. So star, okay, that asterisk is a binary operator which is doing the product term. So if xy through this product term gets z, okay, and what we can say now, xy set belongs to that set, okay, xy belongs to that set, okay, don't get confused here. So see, a binary operator, but this is the binary operator. Okay, so this is the binary operator. This binary operator is defining a set of elements. Set of elements is a rule that assigns to each pair of elements from S a unique element from S. Okay, so let us suppose, okay, 1, 2, 3, 4, 5, something will be there. So, what you so if x y through whenever we are uh, anding x and y, we are getting z. Then we can say, so whatever x, then we can say that x, y, and z, they belong to this set. Okay, so we can say that asterisk is the binary operator of S, and if asterisk is not a binary operator of S, and x, y belongs to S, then we can say that Z doesn't belongs to S. Okay, so okay. If asterisk, this binary operator, if it is belonging to this set, then we can say what is the product which we are getting. That product is belonging to this set. Else, if asterisk is not belonging to this particular set, then we can say whatever the product which we are getting Z, that doesn't belongs to this S. Okay, simple thing. So first thing is, these are the basic definitions. So basic definitions is, the basic definitions means they define these are the common postulates. Okay, these are the common postulates. The first one is closure. Okay, the first one is closure. Okay, what we can say, set S is closure with respect to a binary operator if for every pair of elements of S, the binary operator specifies a rule for obtaining unique element of S. Okay, if we see example, we have a set of n natural numbers. Okay, it is closed with respect to binary operator plus. Okay, binary operator plus. So here the rule is arithmetic addition. Arithmetic addition. Now we can say that for any xy belongs to n, so z is equal to x plus y kada. For xy belongs to, for any xy belongs to n, z also belongs to that. Simple ga antama arithmetic ippudu see all these natural numbers are there in this set. I need not stress this much. So అన్ని natural numbers ఈ set లో ఉంటాయి. ఓకే, నార్మల్ మీరు సెట్ లో ఉన్న ఎలిమెంట్స్ తీసుకొని యు ఆర్ డూయింగ్ ద అర్థమెటిక్ ఆపరేషన్. లెట్ us సపోజ్ z is equal to 2 plus 3 అనుకోండి. 2 plus 3 అంతా z is equal to 5. 5 అనేది కూడా this is belonging to this set. So whenever you are taking the elements from the set and we are performing the arithmetic operation, obviously the result also will belong to this set. That is what. But here, whenever you are using negation operation, okay, negation operation. So negation operation use chesina, sorry, this minus use చేసినప్పుడు ఏమవుతుందంటే if you are performing 2 minus 3 is equal to 1. So what is your result? Z is equal to minus 1. Minus 1 is not belonging to this set of natural numbers. So what we can say that Z doesn't belongs to n in this case. Okay, that's it. Okay, next one is there are some that is the closure, and the second one is associative law. Second one is associative law. What is this associative law? A binary operator asterisk on a set is said to be associative whenever in ledu x into y into z. How can we write x into y z? Okay, where all x, y, z belongs to S. In the same way, what we can write x plus y plus z, x plus y brackets lo unnai, which we can write it as x plus of y plus z. Okay, okay, this product term kaina, sum kaina, associative law is same. Okay, commutative law. Commutative law, x into y is equal to y into x. Okay, so similarly, x plus y is equal to y plus x. For all x, y belongs to S. And third అయిపోయింది. Fourth one is identity element. What is this identity element? A set S is said to have an identity element with respect to binary operation asterisk on S. If there exists an element E belongs to S with the property that E into X is equal to X into E is equal to X for every X belongs to S. Okay, this is the identity element. మనం ఐడెంటిటీ మ్యాట్రిక్స్ అంటాం కదా. సో హియర్ example చూడండి, 0 plus x is equal to x plus 0, so which is nothing but x. Okay, 1 into x, so we can also write it as x into 1, which is nothing but 1. Okay, so this is called as law of identity. Okay, so next one, inverse. Set is having the identity element E with respect to binary operator to have an inverse whenever for every x belongs, ఇవంతా theory మనకు అనవసరం. For every x belongs to S, there exists an element y belongs to S. Okay, so simply ఏంటిది x into y is equal to E. Okay, in the set of integers I, the operator plus over this division with E is equal to 0. The inverse of an element x is minus x, since x plus minus x will be equal to 0. Okay. So next one is distributive law. Distributive law ante x into yz brackets lo unnai, which is equal to x into y into x into z. Okay, so this is distributive law. Okay, so now here the simple thing, binary operator plus defines addition, additive identity is 0, additive inverse defines subtraction. Okay, binary operator, this dot is representing the multiplication, multiplicative identity is 1. Okay, so multiplicative inverse will be there now, x is equal to 1 by x, it defines the division. Okay, it defines the division. You remember this one, multiplicative inverse, it is defining the division. That's it, right? Okay, take it down. So x into 1 by x is equal to 1. And distributive law we can apply whenever we want. Only distributive law is applicable, that of dot over plus. Okay, dot and the product formula. X into y plus z is equal to, we can write it as x into y plus x into z. Okay, so now we are going for axiomatic definition of Boolean algebra. Okay, so we all know that day itself I told you it is developed by George Boole. So here why, on what basis this Boolean algebra is developed? It is on general statements. Okay, on general statements, conditions. Okay, so then it has related to then it has related to digital electronics. Okay, so say there are some postulates, Huntington postulates we call. These are developed in the year 1904. So there are some postulates of Boolean algebra. So here B is equal to 0, 1 in binary, two binary operations. We will be using plus and dot. Okay, so and this is OR. Okay, closure with respect to operator plus and operator dot, and identity element 0 for operator plus and operator 1 for the commutativity with respect to plus and 0. All these things we will discuss. So x plus y is equal to y plus x, x dot y is equal to y dot x. This is the first thing. And if you see distributivity చూడండి, distributivity is so x dot y plus z is equal to x plus y and x plus z. So xy plus xz. And similarly x plus ఇక్కడ చూడండి, ఇక్కడ product term ఇక్కడ plus అయింది, and here whatever plus is there it has become the product term, but the same the law of distributive holds same. Okay, x plus y into x plus z. Okay, you can see here clearly x plus y into x plus z. Now complement అంటే ఏంటి చెప్పండి, x plus x complement is equal to 1 అంతే కదా. ఇప్పుడు let us suppose x1 అనుకోండి, x bar into 0 which will be equal to 1. Okay, a plus a complement is equal to 1, b plus b complement is equal to 1, like that. So x plus x complement, x1 అనుకోండి, complement of 1 is 0, 1 into 0 will be equal to 0. Okay, there are at least two elements xy belongs to b such that x doesn't equal to x is not equal to y. ఇప్పుడు బూలియన్ ఆల్జిబ్రాలో టర్మినాలజీ చూద్దాం. a b plus c d plus ఓకే ప్లస్ ఈ ఇదంతా ఒక ఈక్వేషన్ లేకపోతే ఫంక్షన్ అనుకుందాం. దిస్ ఫంక్షన్ is having how many literals? 1 2 3 4 5. Okay, so these are called literals. A b c d e are called literals. What is a literal? A variable or its complement is called as literal. So a complement kuda 1 literal, b complement kuda 1 literal. Okay, product term అంటే ఏంటిది? Literals are connected by, ఇప్పుడు a b అన్నాం కదా, a dot b literals are connected by dot, that is a product term. Sum term అంటే literals are connected by plus, then it is called as the sum term. Okay, so now we will see axiomatic definition of Boolean algebra. Okay, two-valued Boolean algebra is defined as, you can see, on a set of two elements 0 and 1. Boolean algebra ante 0 and 1 operators again plus dot use చేస్తారు and or not. Okay, 0 0 0 0 1 0 1 0 0. So this is AND gate, OR gate, NOT gate. Why again there is no point of discussing, we have discussed it, right? Okay, so now if we see Huntington postulates for the two binary operators, if we see closure law, 1 and 0 belongs to b, that is, this is the law of closure. Identity law, okay, identity law ante, so we will be using 0 for plus and 1 for dot. Okay, commutative, ఇప్పుడు చూడండి, for binary operators కదా, so we are taking these two operators. Now you see identity law, 0 plus 1 కదా మనం తీసుకుంది, 0 plus 1. Okay, so which will be equal to 1 and 0 into 1 is equal to 0. Okay, so for plus it is 0 and for dot it is 1. Commutative law lo చూస్తే x plus y is equal to y plus x. X dot y is equal to ante 1 plus 0 is equal to 0 plus 1. In the same way, okay, in the same way 0 into 1 is equal to 1 into 0. Okay, it is 0 and this is 0. This is 1 and this is 1. Okay, distributive law lo చూస్తే x into y plus z is equal to xy plus xz. Okay, so z అనేది, if we don't take z, what happens? You see 0 and 1, what is that? 0 into 1 కదా, 0 into 1, y 1 తీసుకున్నాను, x is equal to 0, y is equal to 1 తీసుకున్నాను, or else vice versa. X in which will be equal to what? 0 into 1 plus what? 0 into z. Okay, so which will be equal to 1 plus z. 1 plus z is equal to, you can write 1. Okay, so we will see the proof also for all these things, and see these are the distributive laws. See x into y plus z, which is equal to x into y plus x into z. Okay, so let us try to understand this truth table. Now Rasta x into y plus z is equal to x into y plus x into z. We are proving this one. Now x into y plus z and the y plus 0 and here in this case 0. X into y plus z 0 into 0 plus 1 0. Here also y plus z is 1 but x is equal to 0 0. Y plus z is 1. 1 plus 1 is 0. Okay, and 0 into y plus z is 0. And from here you see 1 into 0 is 0. Okay, so here y plus z is 1. 1 into x1 which will be equal to 1. 1 plus 0 is equal to 1 plus 0 is equal to 1. 1 into this 1 is equal to 1. 1 plus 1 is equal to 0. 0 plus this 1 is equal to 1. So this is y plus so this is so already we have done x into y plus z we have found that. Okay, so this is x into y plus z చూసాను ఇందాక. తర్వాత x plus y x plus z 0 0 x plus y 0 plus 0 0 and y plus z 0 plus 0 0 here 0. Okay, so అలా అన్ని zeros వస్తాయి and finally you can see ఇక్కడ x plus x into sorry x into y plus x into z కదా, x into y plus x into z. Now you see, so x into y x into z, so here you will get 0. Okay, here ఇది చూడండి. Okay, you see this one, we are doing this one. Okay, so 0 0 into 0 0 0 into 1 0. Okay, 0 into 1 0 1 in plus 1 into 0 0 అయిపోయింది. 0 into 1 0 plus 1 into 1 1. Okay, so what 0 into 1 0. Okay, plus y into z 1 into 1 1. Okay, so again what you get here 1 plus 0 plus 1 is nothing but ఏందో తప్పు వస్తున్నట్టుంది. Sorry, here it is already given, right? Okay, x into y x into z 0 we have to just ఇక్కడ ఇచ్చేసారు కదా, యాడ్ చేద్దాం. 0 plus 0 0 0 plus 0 0 0 plus 0 0 0 plus 0 is 0 0 plus 0 0. Okay, and here 0 plus 1 is 1 0, 1 plus 0 is 1 1 plus 1 is 1. So if you compare these two, both the values are equal. Okay, you so from this is from the truth table we are verifying the law of distributivity. Okay, so you can go through it once ఒక్కసారి చూడండి. Okay. So we are performing this operation on xyz and here we are performing this operation on xyz. Okay, so the results if we compare we are getting the same results, hence we are proving the law of distributivity. Clear for all of you? Shall I move the slide?
Madam, 1 second.
Okay. Sure. Or else notepad లో ఒకసారి చూపిస్తాను మీకు కావాలంటే.
Okay.
ఎందుకంటే పీపీటీ పెడితే కన్ఫ్యూజ్ అవుతుంది. What is it? X into y plus z is equal to x into y then plus x into z. So then
Yes, ma'am.
yeah. So now we will take x, y, z. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, again 0, 0, 0, 1, 1, 0, 1, 1, 1, 1. So here we will take y plus z. Now just tell me the y plus z value. 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1 is 0. With carry will be there. We don't consider that carry. 0, 0, 0. 0 plus 1, 1. 1 plus 0, 1 plus 0, 1. 1 plus 1, 0. Okay, this is y plus z. And next, so x into y plus z we have to do, right? X into y plus z if we are doing. X toti multiply చేయండి. 0 into 0, 0. And 0 into 1, 0. 0 into this 1 is 0. 0 into 0 is 0. 1 into 0, 0. 1 into 1 is 1. Okay. So 1 into 1 is again 1. 1 into 0 is 0. No, we should take the carry also. Okay, we should take the carry also if we need to consider. Okay, here and here in this case. So, so what is it? Here 1 and here also what we are 0 into this is 0 only. 0 plus 1. Correct na chudandi.
Correct, ma'am.
Okay. So next this is 1. Last one what is it? So now next one is we will take x into y and x into z. Quickly you tell me. X into y is equal to 0. Okay. 0. 0 into 1 again it is 0. 0 into 1 0. 1 into 0 0. 1 into 0 0. 1 into 1 1. 1 into 1 1. Okay. X and z now you tell me. 0 into 0 0. 0 into 1 0. 0 0 0. 0 1 0. 1 0 0. 1 1 1 1 1. 1 0 0 1 1 1. Okay, so now we should add these two things. What we are getting? X into y plus x into z. Okay, so what we are getting? 0 0 0 plus 0 0 0 plus 0 0 0 plus 0 0 0 plus 0 0 0 0 plus 1 1 0 plus 1 plus 0 1 1 plus 1 is 1 plus 1 is 0 and we will be having carry 1. That carry 1 also you put it here. Okay. Now you compare the result. Compare the result. Both the result is same. Got it?
Yes, ma'am.
Okay. We'll move. Okay, this has been proved, and the next we will go for fifth result, complement. And again, once again, if I revise you, first thing is closure law. Second one is identity. Okay, second one is identity. So a into I plus I into a, which will be equal to I. Okay, so identity. And commutative law, distributive law. Commutative law also, if you y x plus y is equal to y plus x, x into y is equal to y. No need to prove for this thing. Okay, distributive law okati, so it is different. That's why we went for the proof with different values. Okay, from the truth table. And the next one is complement. Complement in the, what is this complement? X plus x complement will be equal to 1. Okay. 0 plus 0 complement is equal to 1. 0 complement ante 1 kada. Okay. And here 1 plus 1 complement ante 1 complement is 0. Okay. So which will be equal to 1. So sixth one is has two distinct elements, 1 and 0, with 0 not equal to 1. Yes, this is the sixth one. Now, set of two elements law, plus is indicating or operation, okay, dot is indicating and operation, complement operator complement operator is nothing but not operation, and binary logic is a two-valued Boolean algebra, okay. Two-valued Boolean, either the value will be 1 or the value will be 0, okay. So there are some basic theorems, and some basic properties of Boolean algebra. Okay, so duality, if we see the duality principle says that if an expression is valid in a Boolean algebra, then the dual of the expression is also valid. Okay, duality అంటే ఏంటిది? ఇప్పుడు a dot b ఉంది అనుకోండి, a dot b in plus c అని పెట్టాను. So what is the dual? Dot you will convert into plus, and plus will be converted into dot. Okay, that is now we can convert it to the duality of this one is a plus b dot c. Okay, so if this is valid, then the dual of this expression is also valid. Okay, dual of the converting the sum into product and product into sum, that is what is called as duality. The expression dual is also valid. So duality is nothing but replacing all the positive plus operators with dot, and also all the dot operators with plus. Okay, so all ones with zeros and all zeros with ones. Simply to say, ones ni zeros ka, zeros ni ones ka replace chestam. Okay, so from the dual of x plus yz అనుకున్నాం అనుకోండి. What is the duality? X plus y into x plus z. Okay, x plus y into x plus z. Now, if you follow the replacement rule, so it will be nothing but x into y plus z is equal to xy plus xz, right? So x into y plus z is equal to xy plus xz. Okay, so the duality మీరు రాశారనుకోండి, x plus y, and this plus will be converted into dot. This is x plus z. Okay, this is the duality. Okay, so ఏం లేదు, మళ్ళీ ఒకసారి చెప్తాను. x plus y z ఉంది కదా. So we are writing it x plus y into x plus z. Okay, so x into y plus z, x into y plus z, you can write it as xy plus z. Okay, you should not alter the locations. Like that, if you see the postulates of the Boolean algebra, x plus 0 will be equal to x, and also x into 1 is equal to x. These two laws are called as identity laws. Okay, identity laws. And next one is x plus x bar is equal to 1, x into x bar is equal to 0. So these are complementary laws. Okay, next one is x plus x is equal to not 2x. 2 అనేది అసలు ఉండదు బైనరీ కాబట్టి x plus x is equal to x. X into x also will be equal to x. X square అనేది కూడా ఉండదు. So these are called as idempotent laws. Okay, so next one is x plus 1 is equal to 1. Okay, x plus 1 is equal to 1. Remember, x plus 1 is not x. X plus 1 is equal to 1. And x into 0 is equal to 0. Okay, x into 0 is equal to anything multiplied by 0 is equal to 0. That holds here also. This is called as law of involution. Okay, x complement of whole complement is equal to x. This is also called as involution, law of involution. Commutative law ante x plus y is equal to y plus x and xy is equal to phi x. This is called as commutative law. Associative law ante x plus y plus x is equal to x plus y plus x plus y plus z is equal to x plus y plus z. Xy దీన్ని bracket లో పెట్టి we put z outside the bracket. This is called as associative law. Similarly, it holds for this AND operation also. X into yz is equal to xy z. Okay. So ఇక్కడ చూడండి లెఫ్ట్ హ్యాండ్ సైడ్ ఏమో yz are in brackets, right hand side ఏమో xy are in brackets. Both the product will be same, the product will be same only. Here in times of addition also the sum will be same. Okay, so this is called as associative law. Next one is x into y plus z is equal to xy plus xz. We have seen just now. And similarly x plus yz is equal to x plus y into x plus z. So this is called as law of distributivity. Okay, so మీరు ఇది బాగా గుర్తుపెట్టుకోవాలి. Okay, this is, you should remember this. Okay, this one. So De Morgan's law, x plus y bar is equal to x bar into y bar. అంటే whole complement మనం బయటికి తీస్తే it will be, the sum will become product. Okay, x plus y bar. This is also very important when you are solving the Boolean equations. Okay, x y bar is equal to, if you are removing out of the braces, x bar, it will, the dot will become plus x bar plus y bar. Okay, similarly this is called De Morgan's law. Next one is x plus xy will be equal to x. Okay, x by, here this one we can prove x into 1 plus y is equal to what? X into 1 plus anything. ఇక్కడ చూడండి x plus 1 is equal to 1 కదా. Similarly అట్లానే y plus 1 also will be equal to 1. So this is nothing but x. X into x plus y is equal to x. Okay, ఇక్కడ కూడా అంటే x into 1 plus y. So which will be equal to what? 1 plus y, again it is equal to 1, which will be equal to x. So these are the postulates of Boolean algebra. You have to practice and you have to go through all these things. It will be easy for you. One time practice is enough for all these things. Okay, so combination allo nenu em cheppina kuda one time practice is enough. That's it. Okay, similarly so theorems are derived from postulates. And what is a theorem? It is a formula or statement that is derived from the postulates. So basic theorems of Boolean algebra. So first one is x plus x is equal to x, x into x is equal to x. If you see the basic theorems, I will set the slides just So theorem 1 is x plus x is equal to x. How to prove this one? X plus x, we can write it as x plus x into 1. Okay. So this is x plus x, you just drop it down. 1 we can write x plus x complement. We can write 1 as x plus x complement. Okay. So next here what we are doing, x plus x is equal to x. We know that x plus x complement x, sorry. So the postulate is also given here. You can see that x plus x is equal to x. Okay, 5a you can see. And similarly, x plus x bar is equal to 1. Okay, x plus x bar is equal to 1 you can write. Similarly, what x you are dropping it down, x complement will be equal to 0. So you can write x plus x bar as ఇక్కడ చూడండి. So you can write x plus 4b, you see, x plus yz is equal to x plus y into x plus z. Okay, or else మీకు ఇంకా సింపుల్ గా చూపించాలి. So what you can do, you can just multiply. ఇక్కడ ఇంకో స్టెప్ వేద్దాము, x into x plus, okay, x into x plus తర్వాత x into x complement plus x complement. Okay. So what you are getting, 0, 0, and you are getting x into x plus x into x. So x into x is equal to x, and here also x into x is equal to x plus x, again it will be equal to x. అర్థమైందా? Got it? See, simply what I did is just the x plus x ni x plus x into 1 I have written. So what I did, x plus x I have written as 1 I have written as x plus x complement. Okay, so ఇది మల్టిప్లై చేసాను అంతే. x into x తర్వాత x into x తర్వాత x into x కాంప్లిమెంట్ x into x కాంప్లిమెంట్. ఈ రెండు జీరోస్ అయితే కదా, ఇట్ ఈస్ జీరోస్. దిస్ x into x, ఈ x into x ఇక్కడ వేసాను. తర్వాత x into x is nothing but x. x into x is nothing but x. Then again x plus x is nothing but again it is x only. Shall I move?
Okay, ma'am.
No. Next one is theorem 1. We show x into x, again it will be equal to x. మళ్ళీ ఇక్కడ ఏం చేస్తున్నారు, x into x plus 0 you are taking additionally. Now simply 0 ante we are writing it as x into x complement. Okay, so now ఈ రెండిట్లో కామన్ x గా తీశారు. So what you are getting, x plus x complement. Again x plus x complement is equal to 1. So which will be equal to x. అంతే, ఇదని ఏం లేదు, కింద పైన కింద చేసి అప్రూవ్ చేయడం అంతే. నథింగ్ is there. If you know all the postulates, it will be very easy for you to get the proof. So x plus 1 is equal to 1. Here also the same thing, x plus 1 is equal to 1. So ఇక్కడ ఏం చేశారు మీరు, 1 additionally you have taken. Okay, so 1 you can 1 place లో x plus x complement వేశారు. తర్వాత if you are multiplying, what you are getting, x into x multiply చేయండి plus x complement into x plus next x into x plus x complement. Okay, so which will be equal to this will be equal to 0. xx plus x is equal to xx plus x is equal to, again it will be x only. Now x complement into 1 we are getting. So we are getting x plus x complement. So which will be equal to 1. Okay, so Next one. Next, x into 0 is equal to 0 by duality. So, or else x complement of complement is equal to x. Now here x complement of and x plus x complement is equal to 1. Simply x into x complement is equal to 0. Okay. So you can go through all these things. Huh? Next one. What with absorption property. Okay. So which is x plus xy is equal to x. Okay. So here what we are doing is x plus xy is equal to x kada. So what we are doing is we are taking additionally x into, if this one x into 1 plus xy is 1 plus xy is nothing but 1 only. Okay. So 1 plus xy it's nothing but 1 only. X into, okay. So here you take out x, it will be 1. Yeah, just wait. నేను తీసేసాను. maybe. Yeah, simply what we are doing here, I will write x plus xy is equal to x. So simply you can do, don't go for any this thing. 1 plus y is equal to what? So x in 1 plus y is equal to 1 only. Okay, which will be equal to x. So x into x plus xy is equal to x. We have proved this thing. So next one is De Morgan's theorem. So De Morgan's theorems, definitely by truth table only we can prove. Okay, x plus y whole complement is equal to x complement and y complement. So we had taken so x y 0 0 0 1 1 0 1 1. Now what is x complement? X complement ante but 0 0 1 1 ఉంది కదా. X complement ante it will be 1 1 0 0. And what is your y complement? Y 0 1 and 0 1. Y complement will be 1 0 1 0 reverse. Okay. So what is x plus y? X plus y is nothing but 0 plus 0 plus 0 0 0 plus 1 1 1 plus 0 1 1 plus 1. Okay, 1 plus 1 0 వస్తుంది but carry 1 కూడా మనం ఇక్కడ పెట్టాలన్నమాట. Okay, so that is what. Next, so x plus y is done. Now what we have to do is x plus y whole complement ఏమొస్తుంది. So whatever the result we have got, whatever the result we have got, we need to find out the complement of this one. 0 complement is 1, 1 complement is 0, 1 complement is 0, 1 complement is 0. So ఇక్కడ now this is done. Okay, ఇది అయిపోయింది. తర్వాత నెక్స్ట్ what we have to do x bar ఇది what is that LHS అయిపోయింది. Now we have to go for the RHS, x complement y complement. Okay, so what is this x complement y complement? X complement into y complement, 1 into 1 is 1. Okay, 1 into 0 is 0. 0 into 1 is 0. And 0 into 0 is 0. Okay. So if you take x plus y whole complement and x complement y complement, both are same. ఈ రెండు మీరు కంపేర్ చేసుకోండి. So if you are comparing these two, so both are same. Next one is ఇది. We will prove this one. X by whole complement is equal to x complement plus y complement. Okay. X complement plus y complement. This one is x complement plus y complement. Okay. So ఇక్కడ ఉంది కదా x complement plus y complement. 1 plus 1 is equal to 1. Okay. 1 plus 0 is equal to 1. 0 plus 1 is equal to 1. 0 plus 0 is equal to 0. This is x complement plus y complement. Now xy whole complement ఏమవుతుంది చెప్పండి. xy whole complement will be equal to ఇది xy కదా. So the whole complement of xy is equal to 0 complement is equal to 1. 0 complement is 1. 0 complement is 1. 1 complement is 0. So x complement plus y complement is equal to xy whole complement. Okay. So De Morgan's theorem we should prove with the help of the truth table only. Is it clear? Is it clear for all of you? Shall I move? Respond. Shall I go ahead?
Yes, ma'am.
Next one is consensus theorem. Okay. So this is a bit different. Xy plus x bar z plus yz. I can write it as xy plus x bar z. Okay. Xy plus x bar z plus yz. We can write it as xy plus x bar z. Okay. So this is called as consensus theorem. How do you prove this one? And second one is also there. X plus y into x complement plus z into y plus z is equal to x plus y into x complement plus z. This is duality. Okay, don't get confused here. We'll try to prove this one. Okay. xy, I'm taking this one. xy plus x bar z plus yz. Okay. So I'm taking the LHS part and I'm trying to prove. ఇక్కడ ఏం చేస్తున్నాను xy as it is. Okay, x bar z as it is. So in the place of yz there is no x term. That's why I'm writing x plus x complement here. Okay. So if I'm writing x plus x complement, so xy as it is, x bar z as it is, x plus x complement into yz. How do you do? X y z plus x complement yz. Okay, x complement yz. So similarly, xy plus xy common ekkada undi, xy plus xyz. Okay, you bring it one side and x bar z చూడండి ఇక్కడ and x bar z plus x bar z y. Okay, same terms ఉన్నాయి కదా, common terms ఉన్నాయి కదా. So you bring the common terms aside. xy plus xyz అని అంటే ఇక్కడ ఇంకొకటి ఏం వస్తుంది మీకు, xy కామన్ గా ఉంది కదా, 1 plus z వస్తుంది. ఓకే, ప్లస్ ఇక్కడ కూడా x bar z కామన్ గా ఉంది కదా, 1 plus y వస్తుంది. 1 plus z is nothing but 1. 1 plus y is nothing but 1. So what you can do, x y plus x bar z. Okay, this is the result you will get. Is it clear for all of you? ఒక్కసారి చూసుకోండి. LHS తీసుకొని సింపుల్ థింగ్ ఏంటిదంటే x ప్లస్ x కాంప్లిమెంట్ టర్మ్ తోటి ఈ లాస్ట్ టర్మ్ ని మల్టిప్లై చేశారు. ఓకే, మల్టిప్లై చేసి దాన్ని ఇఫ్ యు ఆర్ ఎక్స్పాండింగ్ యు ఆర్ గెటింగ్ లైక్ దిస్. ఓకే, క్లియర్ గా ఉందా?
Ma'am, can you explain one time also?
Okay. So here what I am doing is I am proving first one ki మాత్రమే proof చెప్తున్నాను చూడండి xy plus x bar z plus yz ఉంది కదా. సో దీనికి నేను ఏం చేస్తాను అంటే I need to get this one. Okay, I need to prove. So దీన్ని ఏం చేస్తాను xy plus x bar z as it is you keep. Finally, the answer should be in terms of x, z, y కదా. So simply what I am doing is, so ఇక్కడ x plus x complement నేను పెట్టాను. Why? Because x plus x complement is equal to 1. Okay. So that's why నేను ఒక additional term యాడ్ చేశాను. దేనికి yz. Okay. Into yz. So ఏమొస్తుంది నాకు xy plus x bar z plus what is this xy? xyz plus x bar yz. ఓకే సో ఇక్కడ కామన్ టర్మ్స్ తీయండి ఏమున్నాయి సో xy కామన్ టర్మ్స్ ఉన్నాయి కదా xy ప్లస్ xyz ఓకే ఇది ఇక్కడ తీసుకొచ్చాను తర్వాత x బార్ z ప్లస్ x బార్ z y ఓకే ఇదే నేను x బార్ yz ని x బార్ z రాసాను సో xy ఇక్కడ సారీ కామన్ తీస్తే ఇక్కడ ఏమొస్తుంది 1 ప్లస్ z వస్తుంది ఓకే ప్లస్ ఇక్కడ x బార్ z ని కామన్ తీస్తే ఇక్కడ ఏమొస్తుంది 1 ప్లస్ y వస్తుంది సో ఇప్పుడు 1 ప్లస్ x is equal to 1 1 ప్లస్ a is equal to a okay this is one postulate okay that's why xy 1 plus z is equal to 1 కాబట్టి 1 రాసాను x bar z 1 plus y is equal to 1 కాబట్టి 1 రాసాను which is equal to xy plus x bar z అర్థమైందా
Yes, ma'am.
Okay, good. Next one is basic. ఇది కూడా చూద్దాము. Shall we prove the second one also? So better what we will do is you try to prove this one. Okay. So you copy the question. You try to prove this one. ఏం చేస్తారంటే just you take x plus y into x bar plus z into y plus z ఉంది కదా సో ఇక్కడ ఇది ఉంది కదా ఎల్లోతో హైలైట్ చేసింది ఓన్లీ దిస్ థింగ్ యూ మాడిఫై ఓకే సో దీనిలో ఏం చేస్తారు మీరు అని అంటే ఎక్స్ ప్లస్ వై ఇంటూ ఎక్స్ బార్ ప్లస్ జెడ్ ఇంటూ ఇక్కడ ఎక్స్ బార్ ప్లస్ ఎక్స్ ఇంటూ వై ప్లస్ జెడ్ తీసుకొని యూ ట్రై టు ప్రూవ్ ఓకే సో యూ విల్ గెట్ ది ఆన్సర్ ఎక్స్పాండ్ చేయండి మొత్తం ఎక్స్పాండ్ చేస్తే వాట్ యు ఆర్ గెటింగ్ you try it okay we will see tomorrow next one is basic theorems and properties of Boolean algebra so operator precedence untadi kada manamu Bodmer's rule ani brackets of division multiplication addition subtraction ani ikkada kuda entidi anante first priority we need to give to parenthesis parenthesis అంటే ఇక్కడ ఇట్లా ఉంటావో parenthesis అంటే దిస్ బ్రాకెట్స్ తర్వాత నెక్స్ట్ నెగేషన్ ఆపరేషన్ కి తర్వాత అండ్ ఆపరేషన్ అంటే వెరిలాగ్ లో మనం ఇలా డిఫైన్ చేస్తాం కానీ సో దిస్ ఇస్ దిస్ అండ్ ఆపరేషన్ తర్వాత ఆర్ ఆపరేషన్ ఓకే సో బ్రాకెట్ నెగేషన్ డాట్ దిస్ ఇస్ ద ఆపరేటర్ ప్రిసిడెన్స్ ఓకే సో ఎగ్జాంపుల్స్ చూడండి ఎక్స్ వై బార్ ప్లస్ జెడ్ ఉంది కదా సో దీనిలో ఫస్ట్ ప్రయారిటీ మీరు దేనికి ఇస్తారు చెప్పండి ఫస్ట్ ప్రయారిటీ వేర్ యూ విల్ యూ నీడ్ టు గివ్ టు ద కాంప్లిమెంట్ ఈ కాంప్లిమెంట్ కి ఫస్ట్ ప్రయారిటీ తర్వాత next and operation you will give the second priority. తర్వాత you will give the or operation. Okay. So this is the, you need to remember the operation operator precedence. Okay. So next one. So Boolean functions are there. Boolean functions, they have binary variables, operators or and unary operator not, parent not, parenthesis, and constant zeros and ones. So these are the Boolean functions examples, and then we have to derive this function, not derivations. We have to what we have to design these functions. Okay, using logic gates. So these are the Boolean functions. Let me see how much I could be able to cover. Okay, these things we'll see tomorrow. Okay, we'll end the
Okay.
class. We'll end the class for today. We'll see tomorrow.
Okay, ma'am.
Thank you.